Hello. In this video, we're going to go through a question that was made up by a student. During class, we were preparing for a test, and I asked the students, how could I give you a little bit of a harder question? And one of the students came up with this one, which is very nice. So let's do this. We're going to write a method called jumble, which would take a string, length can be odd or even, and return a string which consists of the adjacent letters switched. With words of odd length, leave the last letter in the same location. So we have two examples here. The first is an even example, and the second one is an odd example. So if we call jumble and pass Paul, which is an even length word, we get APLU. If we call jumble and pass it the word Steve, which is an odd length word, we get TSVE, and then we have the E left at the end. So the first thing I noticed with this problem is that let's just deal with even length words. So what I'm going to do is I'm going to write this imagining that all the words are even. Then once I've done that, we'll add a little condition. We'll say if odd length take last letter and the parameter string and add it on. So what I mean by that is our first example, let's do this up here, we take the word Paul. Our second example is Steve, but let's just imagine that it was just S-T-E-V. There's no E on the end. So we're going to write an algorithm so that we only deal with even length words. Because with an odd length word, once I've applied the idea of the even length algorithm, I can just take the last letter and put it on. So this problem has a really interesting approach in that you want to look at two letters at the same time. So if I take a look at the first two letters, what I can do is I can make a temp variable, which is of type string. If I look at the first two letters, so let's imagine I is equal to 0 here. I can add the A, which is in position 1, and add the P, which is in position 0. Then what I can do is I can then look at these next two letters. So I is going to go from 0 to 2. So if I'm looking at the U, I can then take the one past it, which is the L, and then take the U. And then I'm done. So notice, think of it like a bubble that is surrounding two letters at a time, and then I'm grabbing each one in the order I want. And then that bubble moves up 2 spaces. So the question is, so if I, in this case, with the word Paul, let's write Paul here again. Paul is the index is 0, 1, 2, 3, and it has a length of 4. So what that means is if I start I at 0, so I is equal to 0, I want I to reach 2. I do not want I to reach 4. So that means that I has to be less than Paul, the length of Paul has to be the length of Paul. And I'm going to say the length of Paul minus 1 because that way I'm never going to pass this through. And we'll see why this is useful in a second. So let's dive in, shall we? So we have our program here. So this is simply the same question written out again. So the first thing I said I'm going to do is I'm going to create a string called temp, and I'm going to put nothing in it. So now what I'll do is I will create a string, I'll create a loop that starts at 0, and it's going to be less than str.length minus 1. And each time we said I is going to increase by 2. So again, if we pop back to our picture here, if I is 0, what I notice is I need to take the A, and then I need to take the P. If I is 2, I need to take the L, and then I need to take the U. So I'm always going to take the character at the position 1 past I, followed by the one in the position I. So if we come back to our program here, I'm going to say temp is equal to temp plus str dot char at, and I'm going to go I plus 1. And of course, I spelled length wrong. And I spelled char at wrong. So then I'm going to say temp is equal to temp plus str dot char at I. And then of course, once I've gone through that, I'm going to return temp. So let's see what happens now if we run this. I've passed it Steve, and we get TSVE. But again, we said we're going to deal first with even length words. So let's run this. TSVE. Perfect. But we know that the correct answer, if we have the word Steve, is going to be TSVE, and then we add the last E on the end. So what I'm going to do is, after I've constructed temp, I'm going to check if str.length mod 2 is equivalent to 1. What this tells me is that if we take the length of the word in mod 2, if we get 1 back, that means that the word is an odd length. And so what we said is that we'll treat all the words as if they're even, and then only in the odd case will I grab the last character and tack it on. So in this case, I'm going to say temp is equal to temp plus str.char at. And we want to grab the very last character in the word. So I'll say str.length minus 1. And so now let's scroll up here. We see we have the word Steve, and if we run this at TSVEE, let's try a different length. So here we have 1, 2, 3, 4. We have an even count. 4, 5, 6, 7, 8. So when I run this, 2, 1, 4, 3, 6, 5, 8, 7. Perfect. Let's put 9 at the end. Now let's run it. 2, 1, 4, 3, 6, 5, 8, 7, and we've put 9 at the end. And there's our solution. So this is a wonderful problem that a student came up with, and I always like to say to students, come up with your own problems. It's challenging coming up with problems, but at the same time, they're fun to kind of think up, and they allow you to explore things that you otherwise might not see. I'd say with this problem, a really big thing that we want to talk about is that when you're working through a problem, if you're dealing with a couple cases, start by dealing with one specific case. So in this case, we have a case where the word could be odd or even length. But we only looked at even length words first, and then afterwards we dealt with the odd length case. By breaking up your approach, it makes it more accessible. I hope this video helped.